with your quiz corrections as your last review for the exam. This talks about isosceles triangles and just reviews some other concepts. So working through this, you want to be careful to check and make sure you have everything that's on here. Okay, so I have a whole bunch of isosceles triangles, and we might remember that isosceles triangles, anywhere you see them, the angles opposite the sides that are congruent. So this is x, and since these are both congruent, this is 76. So I can kind of work my way around and figure out some different things here. So if these are both 76, 76 plus 76 is 152. So that leaves me with, if I take that away from 180, that leaves me with 28 for this angle right here. And then I work my way over, these two add up to 90. You see that mark on there, so I'm going to take that 28 away from there. That's 62. Which means if you take that from 180, it means I have 118 left to split between these two congruent angles. So you're doing a lot of dividing by 2 and subtracting from 180. So each of those are 59. So kind of working your way around the picture using what you know already about angles. Okay, so here I have an isosceles triangle here, so these angles are congruent. An isosceles triangle here, so these angles are congruent. So I'm going to start working my way around the triangle. This is 72. This is 72. You always want to try to find the numbers first. So 72 times 2 is 144. Take that away from 180, and it leaves me with 36. Well, these are vertical angles, so this is also congruent. 36 here, that means this is 36. So 36 times 2, 72. If you take that from 180, it leaves you with 108 for that top angle. Keep working your way on down. Again, we're using a lot of the properties we already know. So this angle down here, angle 2, is x plus 41. That means this is x plus 41 because they're vertical angles, which means there's an isosceles triangle, so this is x plus 41. I don't know what all I have there, but I know I have those x plus 41s. Now right here we have a linear pair, so 180 minus 122 leaves me with 58 here. And if you look, if you turn this picture, there's your isosceles triangle right here. So that means both of these are 58. And I'm trying to find x, so I need to stop and look and see, do I have enough to find x? Well, I have this little right angle right here. And the secrets of geometry, remember, stuff adds up to 180, stuff's equal, or sometimes stuff equals 90. So these two angles, 58 plus x plus 41 equals 90. So x plus 99 equals 90, x equals negative 9. So I'm able to find that by working my way around. These are kind of good review of all your stuff you've been doing. Next one, I have defined x, and so I know, what do I know? X plus 120 is right here. You can just cross out that 2. And this is 40, and I have an isosceles triangle here. So there's 180 minus 40 left over, so 140 left over to split, which means each of these are 70. And I'm working my way towards the other triangle. That means this angle is 70 because they're vertical angles. And here's an isosceles triangle, so this is 70. I can find that angle, don't need to, because now I have a linear pair, a straight angle, 70 plus x plus 120 equals 180. So that would be x plus 190 equals 180. X equals negative 10. It's not a negative angle, it's just negative x. Okay, now we're talking about the sides, and we know the angles. So if we have congruent tick marks here, this is an isosceles triangle, which means this side right here is 11. Okay, and this picture, we actually have to do a little more thinking beyond that, in that there's nothing marked over here to know what this side is, but if you look at these triangles, they have two sets of congruent angles, and the side in the middle is congruent. So these triangles are congruent by angle, side, angle, which means this is equal to that. Now, if you didn't know what to do on there, if you forgot, when in doubt, try setting something equal. You're never going to use 180 when you're talking about sides. So always try setting stuff equal to each other before you give up on a problem. Basically, we have the same picture here. Angle, side, angle. There's an isosceles triangle here and one here. So 2x minus 2 equals 10. When in doubt, add it up to equal 180. Set it equal to each other, add up to 90. Good. Still, the rule from the first day still works. Okay, if the triangles are congruent, how? The only reasons that you would use here: side, 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 angle, side, angle, angle, side, angle, side, angle, and HL. Those are the only reasons. Don't say vertical angles. Anything you add to your picture is not a congruent statement for triangles. Okay, so I have side, angle, side here, and side, angle, side here. So I'm good in both of them, so I'm going to say they're congruent. Here I can mark a side in the middle there, so I have angle, side, angle, and the same angle, side, angle there, congruent. Always checking both triangles. I look at my picture, I can mark this congruent. I have angle, side, angle again, angle, side, angle, side, 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 side. That's probably the easiest one. I have a side, angle, side, and side, side, angle. Not the same. So NEI, or not enough information, not congruent. You need the angle in between, you need another side, something to help you out. Okay, go to number 12. I can add vertical angles to that. It's not why the triangles are congruent, it's just why the angles are congruent. So I have side, angle, side for both. I always check both. Again, I can add this shared side, so I have side, angle, side, side, angle, side. And the last one here has a right triangle, so I'm going to think about HL, but I'm going to make sure first. So I have two right triangles. These are both right angles because of vertical angles. I do have a hypotenuse, and I do have a leg here, and the same hypotenuse is the same, the leg here. So this is HL. HL only works for right triangles. Last one, little quick review of slope and distance. -3, 1, 2, 3, 1, 2, 3. That's point A. 1, 2, 3, 4, 5. 1, 2, 3. That's point B. Okay. You can use a formula, or you can just note that the formula is just telling you these distances. So that is 6, and that goes from -3 all the way over to 5. So that is 8. So if I want to find the slope, it's rise over run. I go down 6 to the right 8. There's my slope. You can leave it like that or preferably reduce it. The distance, remember distance is squaring those distances between the points. So I already have the distance. I don't need to plug them in my formula. If you like the formula, good for you. Go ahead and use it. So I have 6 squared plus 8 squared. Nice, that's 100, which means my distance is 10. Okay, the rest of the question, what is the slop, there's a typo there, of a line parallel to AB? Parallel lines have the same slope, so -3/4. Any line I make, so if I go right here, put a point, and I go down 3, 1, 2, 3, to the right, 1, 2, 3, 4, or 6 and 8, that's going to be a parallel line. I could pick a point anywhere I want to do that. Down 1, 2, 3, to the right 1, 2, 3, 4. Any of those lines are parallel. Perpendicular is the opposite reciprocal. So the opposite sign makes it positive, positive 4/3. Anywhere I pick a point, I'll pick a point right here and I make a slope of 4/3. Up 4, 1, 2, 3, 4, to the right 1, 2, 3. It's going to be perpendicular to all those things if you extended them. Okay, good little review. Do your quiz corrections, do this review in the CUDA, and Make sure you're always ready to explain yourself on the final.